Welcome. In this video, I'll just show some aspects of implementing a machine learning project, right? Machine learning, graph learning project. So this is the third video, third step. So in the first, we just gave the project overview and the steps for the implementation and considerations and some overall how things will go. And in the second video, we showed the code as well from the stock market data set. How do we create some sort of graph using different correlations? Okay, so I probably need to give you some background information, right? So the paper that I'm implementing here, it's about, let's say, stock market price prediction using machine learning, deep learning, and graph theory, right? So I think the idea was stock market data set, stock prices. We'll study the correlations among different stocks and their prices, and we'll create some graphs. If multiple stocks prices, they have some connection in how their prices moves, we create some sort of node edge graph, right? So that's how things work. Just watch the previous videos, right? Okay, so we use Pearson correlation based graph, Spearman and Kendall Tau, right? So what does it mean? Two stocks, two node in the graph. If they have a Pearson correlation greater than 0.5, here there is two stocks. If their Pearson correlation is less than 0.5, don't create any edge between them. So that is one graph. And then we took again data set, two stocks. If their Spearman correlation is greater than 0.4, then Pearson is, that's a different graph, right? Pearson graph is one, Kendall Tau is one, Spearman, three different graphs, right? And financial news-based graph, we did not make it yet, but we need to go there, right? Okay, watch the previous videos. Now in this video, okay, graph is there, right? Graph is there. So now it's about, I think we need the feature, right? In the first video that we told that in the graph convolutional network, one input is the graph structure, but it does not have the pricing information. Yeah, pricing information was used to create those graphs, but the graphs at this moment does not have the pricing information, right? So another input that will have all the historical pricing information, right? That is a, you can say one vector for one stock, or you can supply it as a matrix, right? A feature matrix, and the previous the graph matrix, graph structure. So yeah, any other graph convolutional network, it is some sort of the paper that the way it is used, graph convolutional layer and the CNN layer, graph convolutional layer, CNN layer. Okay, so here I'll be trying to create something like this. However, at this moment, I am just experimentally using one graph neural network sample example from a place. Now, I think at this point, what I'm trying to do, if I can feed the input to a graph neural network, right? The structure that I will make my own, or I will adjust it in such a way so that it fits the paper, or probably with some customizations from my understanding. But my goal is, if I can fit something, or if the matrices are ready to be fed, and some sort of graph neural network can work on them, and I can get some output. That's where I am, right? So yes, I will need to modify this, adjust this, and create my own model from my own understanding, and using multiple different helps, not definitely exact of other things. And this paper that I'm trying to implement, so far I did not see any code for this paper in the internet. So yeah, the authors did not give any GitHub repository or any link that's code is there. So I'm trying to figure it out on my own. Even the dataset, I did not find the exact dataset this particular paper has used, but that probably will be one of the goal that try to find out that exact dataset and see how my implementation works and what is the output that I get, and compare those output. But in general, I still have the for my test data set, I have the prices and my model. whether it will predict the price. So I'll try to see how much error I get or not, right? Okay. So at this moment, getting high accuracy. Okay, so far is not my goal, but at the moment, I can just let me see how things go. And then the fine tuning part in future. Okay. Anyway, so let's share some code, right? Okay. This is not what I wanted to open. Okay, let's go there. No, this is not the right one. Let me see. Okay, this is the one. Yeah, the other one, it's just a previous version. So far we saw this code, right? So these are the graphs. This is the Pearson correlation based graph. This is the Spearman, and this is the Kanda. Okay. Now for the graph, right? For the graph neural network, one input will be the graph, right? Graph, the node is the uh, stock, and edge just shows that whether correlation is there or not. Okay, is there, is not. And then and the feature matrix at this moment, I'll be supplying the historical prices for each of the stocks in the graph node, right? So it is based on the closing price. In some experimental design, some other cases, uh, each minute price was used, but let's skip it for future. For now, each day closing price for the selected stocks in the graph. Okay, so that's what I'm trying to identify here. So finding out all the uh, stock node. I think this is the Pearson correlation. Okay, finding out all the stocks, right? When I'm doing it, I'm just one thing I'm thinking. Let me see. So if I am taking all the stock name from the original Pearson correlation graph, original correlation matrix, there may have some mistakes there, right? Because I will take only those stocks that are in the graph. Now, original Pearson, okay, let's see. So, okay, I need to setting exactly from where I created those graphs, right? I created the graph. I actually need to take the node from the graph because the correlation matrix is still if somewhere I have 0.0, there is not supposed to be any edge in between them. So that stock is not supposed to be on the graph depending. They can be there provided some correlations with others, right? But if two stocks has no correlations with anyone, but in that case, they are not supposed to be in the graph. So that's how, so this just taking for the correlation matrix, all the stock nodes. So that may not be correct, right? So that is something to improve. Okay, let me say, so it was good that I Okay. Okay. Yeah. Now it is just traversing through. Okay. No, at this moment, let me see. It is even before creating those graph, right? Even before creating those graph, but the graph is already there. Okay. No, it is not for that purpose. What I'm trying to do here is it's a different thing, right? So it's a different thing because the graph convolutional network, right? Those are the graph. Yeah, I am right and wrong in both ways because I'm just two different contexts here, right? So this one is just for the uh, depending on the correlations, right? Depending on the correlation, this is that graph, right? Now there is one another graph. That graph is the graph that will uh, fade into the GCN, right? That that is some specific styles of graph, right? There's some specific styles of graph. I'm trying to form that graph. I think there is some built-in method for the GCN uh, mm, to use some sort of graph or use the graph data in some uh, particular form. I'm just trying to make it like that, right? Let's say. So one thing is, let's say the way it works, the graph convolutional network, that is Stellargraph, the library, that the way it uses, we need to supply the graph as source and target, right? An array of source is series vector of source, a series of a vector of target. That means source and target, all those edges. I think we need to supply all the edges. And the features, we may or may not need it, but I think we might have tried to do in that. But yeah, that's probably what I'm trying to do. Okay, so the graph is there. Okay, so the Pearson correlation graph or all the correlation graphs are there, right? Now my point is, before I fit this into some graph neural network or this corresponding model, even for that model, they want to see graph in a particular format, right? So that's what I am aiming for. So I'm just trying all the source and the corresponding target, two different arrays or vectors or whatever you say that will represent that. That's what I'm trying to find out. So source and target, right? If the correlation is greater than 0, because here, if there is an S, it will be 1. If there is no S, that will be 0, right? And the first step of point greater than 0.5 or not, that's that we already dealt with, and we came up 1 or 0, whether there is an S or not, right? So if there is an S, create S. If there is no S, do not create S, right? That's probably how things go. Okay, S, and then I'm just separating out sources and targets, corresponding things. Okay. So just outputting source and target. S feature. I'm just this is for now it's dummy, right? For now it's dummy because it looks like at one point when I was creating input, graph related input for the graph convolutional neural network, it looks like it was expecting that it is telling that it doesn't have any features or some missing features. So I was trying to see, at least manipulate it in such a way. Let me make it work. I think my goal was create a graph neural network model and make things work with the input. Yeah, there are some imperfections, even something that is not valid, but that's for later. Just make things work, and then I will trace back and make it working, right? Now, actually here I'm trying to create a feature for the edge, but actually the graph convolutional neural network, or the way I will eventually implement, or the way the paper has told, it actually the features are for the nodes. So this edge feature eventually I will discard it. I believe I have reached to the point where I am not actually using it. I'll be using the features as part of the node. And the features, what does the feature mean at this point? The feature mean the historical prices, the time series. That is what it is about, right? Okay, this not, but okay, I'm not removing because I'm using this code in letters. Okay. So Pearson edges, source and target, Pearson edges data. Okay, this is uh, source and target, source array, target array, source vector, target vector on a parent vector kind of things, right? Parent data. Okay. I'm doing it because that library, the graph creation related library method that needs graph data in this format. There are multiple ways of doing it, right? One thing is you can load from the graph comes with some data set. you can load it from there, but I did not check if the stock data is there, but it may be there. That could be a good place, but that is one way of passing this data, passing graph data, one of that way, and this another way. I'm using data frame. I believe I have seen. Okay, this is the one I'm referring to. Okay, so in this reference, right? Wait, this is our second video. No, I think, let me see. Not okay. So it is how to, for the Stellargraph graph convolutional network, the way you want to supply your graph data. If you are using pandas data frame, this is the reference manual. Okay, so let's see. So source and target, they supply it like this, right? So you can use the graph, some Stellargraph. This Stellargraph will be fed into the GCN graph neural network. So you create the Stellargraph as an input, our initial correlation graph, that is one step, and then Stellargraph, and then I'll be feeding it, right? In this case, it is just only the edges, but they're not supplying any features. So there are different things to edges and the nodes features. There are multiple things we can pass through this Stellargraph method, and then we can see how things. It is just showing the graph they created. So this feature is none, this feature is none, no feature is there for these cases. But in some cases, you can supply the features none. Okay, yeah, not feature. I will also be using some sort of this sort of syntax. Yeah, context, yes. Yeah, I think it is a reference manual, right? So there is nothing harm that you follow the reference manual and create your own code, right? Yeah. So you can say feature is there or not, edge feature is that. Yeah, right. So in that case, you supply square node data and square edges. So you supply both edges and the node information, right? Node is features. So that's how we got it. In the first cases, we just supplied square edges. This is just some labeling, but it is not something. So if I go here, yeah, it's just only edges. So there is no node feature. But when we supply some node feature, then we get some output that tells that features are some numbers, right? Let me see. In our case, yes, we need features. We need the feature vector for the nodes, and definitely the graph is structured, Stellargraph. So that will be the input that is coming from those. Okay, anyway. Okay, in this case, I think we'll be mixing things, both node features and the edges will be mixing. Okay, here, right? Okay, so at this moment, using this will be enough, I think, eventually, because I think for my purpose, edge feature, I don't need edge feature at this moment. In this cases, the weight is not that important. I think, but the financial news-based thing, they are the weight will be important. But for now, weight is not important. So the edge. Okay, this is what I got. Okay. Okay, this is a Stellargraph that I'm using. This will be used as a in the model. This is how will be supply edges, node type. Okay, this is not the final thing. It is just still was experiment. What happens if I just do it? I think in the beginning I tried to create this graph only with the edges, without the node features, and see how things go. And then eventually I went to the stage that where I can create the edges, create the Stellargraph using both edges and nodes with node features. Okay, yeah. So it took some trial and error and understanding, and then fixing things. Usually things do not work as is. You need to do some manipulation, and eventually you understand things and you can get things right, right? So yes, at this moment, I believe my Stellargraph is okay. Now the GCN, that's where I am. Still, I believe it started working to some extent. At least the model executes, compiles, and does something and creates some training accuracy, testing accuracy, all those things it can still bring, right? So some progress is there, but it is not perfect, or it is not where my part, the model that I need, it is not there yet. I will need to work on that part, right? So let's see. At this moment, the graph is only the edge-based graph, right? So, okay, I think from that structure that we have some I believe the historical stock market prices, right? Historical stock market prices. Let me see. Okay. Okay. I think that data structure that we have, it is not in the exact format. So I needed to do some sort of manipulation, I think, finding out all the series and do some moving around and create in such a way so that the node feature matrix, it comes into that way, right? My eventual goal is finding it this way, right? My eventual goal is finding it this way. And I believe the data was, if you watch my first video or second video, yeah, I think the raw data was a different format that eventually I got into the ticker, and all the time series data and all the dates, right? I needed to remove the date and keep only the prices, vectors, time series, right? So that is the manipulation here. Yeah, it also needed some sort of tricking, right? Some sort of tricking to come to the end. You can see, I think for this block, I probably tried it 10 or 20 different different ways to see how I can get back to it. Yeah, there are some tricks there. Eventually something worked. Yeah, worked, but still I probably will need to see it. Probably is okay, but I may still need to change it for my graph convolutional network to be able to work with it. Okay. Okay, let me see if I just kernel, restart and run all. I'll just run everything one more time. I'm running it so that if I want to show you any code or execution, I can show you. But at this moment, I'm showing it from the previous run, so you probably do not know. I think it may not be clear to you, rather than see you do not know, right? Okay. Okay, I think creating the node feature matrix, that's where we are. Let me proceed first, proceed a bit, and then I will come back and show you the little bit of the data. Okay, let's see. So this manipulation, okay, how far it went. Okay, still training, testing. Okay, anyway, it failed. Let it fail it. I think when I ran the last time, I'm not sure it failed. It probably did not, but I may be wrong. Okay, let's say I was creating the node feature matrix, right? Yeah, it looks like I will need to review. Probably I will review this code again in the another video, so that it looks like I just messed up a little bit. But I just went off topic or this and that, right? Okay. Okay, let's see what does this look like. You can see the date is there, right? But I don't want to pass date as part of the node feature in the GCN. So I need to move it. So index reset and then values. So for all of the stocks, I'm just finding it out and then okay, eventually this is how I got into it, right? Okay. Now I'm clearing the Stellargraph. I'm supplying for node feature data and the age information, if there is an age or not, what are the ages. And this Pearson edges, what does it has? It has source and target, right? Source array, target array, source to target, one-to-one mapping. All the edge listed, it goes in there. And Pearson graph node data, this is what I am sending there, right? So it looks like if I transpose, it shows like this. So I'll need to see if I need to send the transpose or not. But what I did, I think I probably need to get back. Okay, this is one of the Stellargraph method, GCN related graph, right? GCN graph input the corresponding graph with edge information, structural information, and the node feature or node stock price histories. So for node features is there, and for edge type features none. But I think we did, let's see, Pearson edges with the data. We created one another data frame that we could supply here, or data frame or something similar. So that could also, I believe I have code for that here. Node Pearson edges. This is just giving a little bit more anyway, GCN. So this is the with edge features. This is node features. Okay, I believe I think the node feature, that is the Pearson edges node. I think the naming does not look right. My understanding was I did something more. I might have removed and kept some mistakes. Anyway, I think you got the idea, right? I think graph node, this is enough. Pearson graph node, node features, and Pearson edges. That should be enough now. Whether I need to send it in transpose format or not, that probably something I need to see how that fits into the graph neural network and graph convolutional neural network. Okay, this is still experimental. Train test split. So I'm just using some default way that different graph convolution and graph neural network used. So just to see if I can make things work, right? So from that, because model selection train test split, I'm just trying to supplying the node feature data and then train test split. So some sort of thing. So I'm just using the node features, right? Node features, some for training and some for testing. I believe the graph structure needs to align with this, right? Graph structure needs to align, or some sort of thing needs to be there. Okay, it looks like I did not put much thoughts, or I did not do much work on that aspect. Probably this is something that I need to dig into and see if I have done it right, or if I have put thought. So, but I did not, so far I did not to put any thought yet. Yeah, this is something to be done at this moment. Just experiment that if I can do some training testing and so using some model, can I pass this data or not? I think understanding input data and formatting it correctly, that's probably one of the important goal, or the primary goal, and then a little bit on the GCN training testing side and see where things go, right? Let me see. So this is the train test thing. Okay, these two things needs to match. This validation value subject and test subjects, validation subjects and test subjects. These two needs to match the dimensions, right? So this is the training, this is the testing. Okay, so, and this is the validation, right? So from the testing, we are just doing one further step to get to match the shape. We're just taking some of them. This part is doing this part. I think the naming, yes, this is not a good practice to name something like this. I just are doing something quick, but yeah, eventually when I figure it out, what is the correct, what I finally want to use, train test split, whatever way, then I probably will fix the variable name as well. Okay, this is not a classification. This is a regression, right? So if it was a classification or binary classification, so you could use some sort of fit transform or label binarizer or some other some multi-class classifier related things and convert this data into something in this train and target. So yeah, I think that target, right? Target, I think if it is a classification, you need to move them into different classes, right? I think for me, this is regression, so I do not need to do it in the regression. So this is in the classification, you do it, but in the regression, you don't do it, right? Okay, this is where I'm creating the graph convolutional neural network, and then I'll be sending this my data. So input output, the target, that is the predictions. This is the model. Input is the X input, and output is the predictions. Predictions is the target, right? The target variable is there. Input is there. Yeah, training subjects, validation subjects, and test subjects, and then the targets, right? Okay, it is just the tensor, the deep neural network. They work with tensor, right? And for this last losses, because I'm using regression, so mean square error. If you are using classification, then you will use a different accuracy or something like this. No. I think, let's see, for classification, yeah, there are different matrices, the precision, recall. Okay, let's not go there. I think cross entropy, or I think the KL divergence. Yeah, I think there are some corresponding terms in the library, so you could use it. So it's regression, Adam, and learning rate. Okay, matrix accuracy. Okay, this is the tensor shape. Validation generator, train generator. So this is, I'm trying to execute the model, right? Train generator data. This is the validation data. So training data and validation data that what I'm using. Data validation generates. And validation generation is coming from, okay, it is coming from somewhere in the validation in the earlier cases. So, okay, so 2000 epochs. So this training accuracy, testing accuracy, accuracy and loss. Okay, I'm not expecting something good here. It also looks like the data matrix, the way I fed it. As long as, okay, they are this direction, right? This is how it is. It looks like the transpose probably can be a better way of sending it, but I still need to see it. So this is the testing, test generator, test matrix. This is the loss, accuracy. Okay, so it looks like accuracy is not good. Okay, it's okay. It failed. I think it's not it's still there. Yeah, I think at least I could create some graph convolutional neural network and then feed the data, could uh, uh, run the GCN and model and all those things. So everything is there. I could compile it as well. So it will be now a matter of using more data so that the deep learning can make sense. And the node feature, the way I want to send the data, if that is appropriate or not, that is one thing. And definitely, this is something I want to use. It looks like I have used some the default things, or default or some common. Okay, let's see if it works or not. I just changed the dropout. Okay, I think that's the mainly the video where it ends. Okay,